sharing. Okay, right. Yeah, morning, dear students. So last session we have started the cantilever method, the other method in uh, approximate methods for laterally loaded frames. So last session we have talked about the procedure. To start with, you have to calculate column axial loads first, then column shear, then beam shear, then beam end moment, then column end moment, then column shear. Okay, so this is the example problem that we are going to solve. This is one of the questions from the university question paper. So it appeared in October 17 that analyzed the following frame using cantilever method. Okay, so look for the method which one is asked. So there are lateral loads applied at each floor level. So it's again a three-storied, three-bay building frame. So 20 at the top floor, and then middle floor 30 kilonewton, bottom floor 40 kilonewton. So this is how the loads are, and then spans are 3 meters, 4 meters, and 5 meters. Then the floor heights 3 meters, 4 meters, 5 meters, same as this spans order. Right, so start giving the names for the joint. So notation for the joint A, B, C, D. As you wish, E, F, G, H, I, J, K, L, M, N, O, P. So there are joints like this, and the members will be called with that joint location. Say member AB is a beam, BG is a column, GF is a beam. So likewise, and P, O, N, M are the bottom supports. So this is the frame given. So let's start with step 1 to calculate column axial loads. Okay, so for that what you need is first put assumption 1, then prepare the frame. Okay, so draw a frame, given frame, then apply assumption 1, then prepare the frame. So assumption 1, you know very well that the middle of each member you need to have an imaginary hinge. Okay, nothing but zero bending moment location or the point of contraflexure. Right, so going for step 1. So in the procedure, step 1, it is told that first locate CG of columns. Okay, how to locate CG of columns? This is the way that we will proceed. So just recall the formula for finding center of gravity from your engineering mechanics. So x bar is equal to a1 x1 plus a2 x2 and so on, divided by a1 plus a2 and so on. Okay, right. So a1 means first column and x1 means distance of first column from reference line. Okay, so here I am taking the reference line as the first column itself. This is the reference line. Okay, so it is mentioned, right? This is the reference line. Okay, first column itself. So from reference line, first column distance is 0. That's why first term is 0. Then second column, cross-sectional area, assume some value because it is not given. So small a is assumed. Cross-sectional area of all the columns are assumed as same and it is small a. X2 means what? From reference line, second column distance. How much? 3 meters. Right. A3 A. X3 means third column distance from reference line. Value 4 plus 3, 7. Right. Fourth column. Area X4. Distance from reference line. 3 plus 4 plus 5, 12. So total 7 plus 3, 10 plus 12, 22A. Divided by A1 plus A2 plus A3 plus A4, 4 times A. So what is the value? 5.5 meters is the CG location. Now let us just draw CG location. Is this CG location? 5.5 meters means what? 3 meters. Then middle of this is 3 plus 2, 5, 0.5. So middle bay to the right of the center of middle bay. Is it okay? To the right of center of middle bay. This is the center of middle bay. Middle bay center is this. Means 2 meters and 2 meters. So 0.5 to the right of it. 5.5 meters. 3 plus 2.5. Okay. So from reference line, what is X bar means? From reference line that you have taken anywhere. From reference line, what is the location of CG? This is the X bar value. So this is how you found CG of all columns. This is the first and foremost calculation you should complete before you apply assumption 2. Okay, so now let us see assumption 2. So take a section in the center of each story. So let's talk about the top story. So pass a section through the center of this x. Then take this part above the section portion, draw it as it is. That is what is this. Okay. So this is where the point of contraflexure is present in the diagram. That is where you have taken a section, and 20 is the only load that you can see above that line. Okay, so top story height is 5 meters, so you cut at the center, so 2.5 meters. Okay, now what? So you have drawn that portion of the frame, and this is like 3 meters, this is like 4 meters, and this is 5 meters. So you have drawn all this, right? Now what? So wherever you have removed the contact by cutting the columns, there you need to show the reactions, right? So how many reactions will be there? Actually speaking, 3, because you cut the columns. You have cut the columns. So actually speaking, 3 should be there, 3 reactions. But you have cut at exactly middle, bending moment 0. So there will be horizontal force and vertical force. Okay, but we don't want horizontal reactions. We want only vertical reaction. Column, because your assumption is on what? Axial stress is proportional to the distance from CG is your second assumption. Okay. So axial stress means axial load by area. So axial load you want. So we want only vertical forces. So just represent vertical forces. Means axial loads, right? Vertical force for a column means what? Axial load. Okay. Now that is one thing. Next, how I kept these arrows. So some arrows are downward, some arrows are upward. How I kept those arrows. Okay, the reason is, see this 20 kilonewton meter. See, this is the CG point. Okay, so this 20 kilonewton meter is rotating this frame clockwise. Okay, right? The resisting moments should be what? Anti-clockwise. So to have anti-clockwise, the left columns should have downward force, right column should have upward force. That is what is being given. The same is the notation. So left columns downward forces, right columns upward forces. So these column axial loads will try to resist that bending moment applied. So applied is clockwise and reaction is anti-clockwise. Okay. So this is how the why this downward arrows and upward arrows. Okay, right. So this is the next step. Got it? After completing CG calculation, what you need to do, pass a section in the middle of the top story. Take the part which is separated from the section above that section. So that part you draw as it is. Right. So that's the first thing to do. Then what? You represent the arrows axial loads only, because we don't want the horizontal forces, because your assumption you are going to work with only axial loads, because your assumption is on axial loads. Right. So how you represent axial load is by looking at the applied moment, by the applied load. So applied load is towards right, so that is going to turn the frame clockwise. So you should have anti-clockwise moment. So for that, what you need, CG line to the left of CG line. This is CG line. This line is CG line. Okay, so 5.5 meters from the first column. Okay, right, from CG column to the left, downward arrows, right upward arrows. Right, this is the frame, part of the frame ready for assumption 2. This much you need to do. Now you take the assumption. So notations as it is, FAH is the force, axial force, FBG, FCF, FDE. Right. So what is the assumption? Sigma is proportional to X. Got it? It's simple. Axial stress is proportional to the distance. Okay. So now just elaborate. F by area is equal to, okay, some technical extra line, so that we can always correct it, no problem. So equal to, proportionality is removed, so can have some constant K X. So what you have now, so F is some force we don't know, A we have assumed it as small a divided by x is equal to some constant k. Right, so this is what we are going to do. Column axial load divided by column cross sectional area whole divided by the distance is equal to some k, some constant, proportionality constant. Okay, so likewise you do it for all the columns. So now what is x? Distance of a column that you have taken from CG line. Got it? So from CG line, what is the distance? Okay, so that you forget. Which one? Till you calculate centroid, the distance means what? A1, x1, a2, x2, a3, x3. What is x there? Distance of column from reference line. For finding CG, once you know CG, then the distance means what? Distance of column from CG line. Okay, right. So FAH divided by small a, distance of this column AH from CG line is 5.5 is equal to, likewise I can apply for all the columns, right? So FBG by a divided by distance of this column from CG line is what? 5.5 minus 3, 2.5. Then this right hand side, FCF by A, okay, divided by this value is 4. So what will be this value? That's it. Okay. So this is now 2.5. So 4 minus 2.5, 1.5. So 1.5 plus 5, 6.5 for the last column. So is equal to k will be there. We don't want it. Anyhow, we'll be going with the proportionality. Okay, some a equal to b, b equal to c, c equal to d, like that. So equal to k is neglected. We don't want that. Right, now what to do? This is the second assumption applied. That's all. Okay, from that, how you calculate column axial loads is much important. Okay, right, now you relate all these column axial loads into one column axial load. So you have 4 unknowns there. Okay, so you relate the other 3 to one selected column. Okay, so here I select the first column. I select first one, FAH. So I relate FBG and FAH, FCF and FAH, FDE and FAH. So what I do, I write FBG is equal to, what happens? 2.5 goes to numerator here. A and A gets cancelled. So 2.5 divided by 5.5 into FAH. So this is the relation between these two column axial loads. Same way this one. So 1.5 goes to numerator, divided by 5.5, and A gets cancelled. Likewise, all three. So 6.5 divided by 5.5 FAH. So FBG, do this value with your calculator, and these are the relations. Okay, got it? So just simplify that into, okay, right? So next thing. So let's clear all that lines drawn. Okay, otherwise it is going to be clumsy for what we see there. Okay, right, so let's go back to the presentation. So we got these relations. Then let's see how you find all those 4 values. Okay, now this is what you have. Take moments about midpoint of AH. Means what? This one. Bending moment is 0 there. Okay, take moment about this point of all the forces. So that is your equation. Okay. So there are 4 unknowns. You have got 3 relations. You see, I have got 3 equations. I say 1, 2, 3. You need one more equation. You have 4 unknowns. So that fourth equation is this one. So we take moments about AH. Okay. So that's how it is. 20 into this distance. 2.5, 5 by 2, 2.5 clockwise. FBG into this distance is 3 clockwise. Both are clockwise. This is clockwise and this is also clockwise. And this is anti-clockwise. These two are anti-clockwise. FCF and FDE. That's why they are minus. See, minus. Right. Into 7, this distance. 7. And this distance is 7 plus 5 again. 12. Equal to 0. Right. Now what? You have what is FBG value. Substitute it here. You have what is FCF. Substitute it here. You have already FDE. Substitute it here. So in all these equations, in the entire equation, FAH is the only unknown, and that is this value 3.394 kilonewtons. So once you know FAH value, then substitute back into the earlier relation. So you know FAH now in all these 3 equations. Now you are able to get all these DE, CF, BG value. Okay. So this is how we solve for all 4 column axial loads of the top story. This is for only top story. Okay. Right. So let's see all other stories in the coming sessions. Thank you.